teaching platform. This is Mr. Mlonga, aka the teacher. My pupils calls me the teacher. We are here to do mathematics indeed. Be ready for the lesson that is coming forth. If you are new to this channel, you are welcome. Please subscribe so that every time we post a video, you are the first to be notified. When we say collinear vectors, we are talking about vectors on the same straight line. For example, if we can have a line like this, then we have a point A, then we also have a point B, and there is also a point C there. If the vector at this point and the vector at that point are collinear, then we can say that BC is equal to KAB. This is the rule which shows that vectors are collinear. One must be a scalar multiple of the other, such that this BC is K times longer than AB. So in this case, we have these two vectors, AC and BC. Now we want to show that they are collinear. In this case, if these two are collinear, then it means that we should have AC is equal to KBC, like that. They must obey this rule. So let's try and substitute into that. Our AC is this one, so we have a 4, a 3 there, then this should be equal to K, then BC. Our BC is that. So 2, then 1.5, like that. Open the brackets on the other side. You're going to have 4, 3 equals 2K, then 1.5K, like that. When that is done, you can now equate in correspondence the first and the first, the second and the second. Hence, we're going to have 2K is equal to 4. When we do that, you can divide by 2. You can divide by 2 there. Then this will go with that. Therefore, K is going to be equal to 2. Okay? The proving factor is the point where we get K being the same. So we can use another equation at this point. We should also consider 1.5K is equal to 3. Hence, we have 1.5K is equal to 3. Divide by 1.5, even there by 1.5. This will go with that. Then you have K is equal to 2. Now that K is coming out to be equal, when we use the first equation, K is equal to 2. The second equation, K is also equal to 2. Then it means that actually AC is equal to K is 2. BC, like that. Hence AC and BC are collinear vectors. So to be collinear is to be on the same straight line. Then the rule is that if vectors are collinear, then one must be a scalar multiple of the other. If the two vectors are collinear, then one must be a scalar multiple of the other. In this case, this is a scalar multiple of that, which shows that this AC is K times longer than BC. When you find that K is equal to 2 and there K is equal to 2, then it means that the two are collinear and they satisfy the rule. We have another question. If A is that coordinate and B is this coordinate, then C is also that coordinate. And these coordinates are collinear, meaning these coordinates are on the same straight line. Show that AB is equal to KBC. This AB is a vector. BC is also a vector. So what you do first of all, you find vector AB. AB is going to be equal to AO plus OB. So then you substitute AO. this is A. This A means OA. OA, but this one is AO. So it's opposite to that. Hence, you have to change the signs there. You say 2, 2, like this, plus OB. OB, this is the same as OB. So there's no change of signs. Sorry, there's supposed to be an arrow. Then this will just be 2, 1, like that. From there, you can now add the column matrices. 1 plus 2 will give you a 4. 2 plus 1 will give you a 3. This is our AB. After finding AB, you also have to find BC. You say BC is equal to BO plus OC in this case. Then BO means from B to O. This means O to B, so it's opposite. Hence, even in this case, we have to change the signs. So instead of 2, 1, it will be -2 and -1. Then plus OC is the same as that. So we have a 10 and a 7, like that. Then from there, you just add the matrices. 2, that is -2 plus 10, it will give you 8. -1 plus 7, it will give you 6, like that. This is going to be our BC. We now say AB, which is going to be equal to KBC. KBC. Where there is this AB, we'll write this. Hence we have 4, 3, like that, equals KBC is that 8, 6, like that. Then you open the brackets. When you open the brackets, you're going to have 4, 3 is equal to 8K, then 6K. When I say open the brackets, I mean to multiply this K by everything inside there. So from this point, you are going to have 2 equations. There is this equation where 8K is equal to 4, so we are saying 8K is equal to 4. Then there is also another equation where 6K is equal to 3. 6K is equal to 3, like that. Find K. You divide by 8, even there by 8. This will go with that. Then K is going to be equal to 1/2. Because 4 there, 1. 4 there, 2. So this is our K. Then after finding this K, you also do the same the other side. You divide by 6, then you have K is equal to 1/2. Now that K is coming out to be the same, it means we can be able to express it in this form, or to show, because we'll just say AB, our AB is this, that is 4, 3 is equal to, our K is half, then BC is this one, that is 8, 6. When you do that, you have already shown this is the same as half times 8, it will give you 4. Half times 6, it will give you 3. Hence, shown. So the end of our lesson. Please, if you have not subscribed, this is the time to do so. It's mathematics all the way until Jesus Christ comes. Take a minute of your time and imagine the world without mathematics.